Math 113, lesson 5.5 is graphs of sine and cosine functions. So I do want to give you a little warning. This might be a little lengthy. I'll do the best I can for speeding up the process. So we're going to start with graphing the sine function. Y is equal to the sine of x. So the first thing we're going to do to graph this, so that we can get some bearings under us about how in the world to do this, is we're going to start with we're going to make a table, and we're going to start with some values of sine that are located on the unit circle. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Those are values that are radians on the unit circle. So it helps me be able to find the sine of each of these. So the sine at 0 degrees, if we pay attention to the unit circle, I'll sketch a little unit circle here so you can see. Remember, the unit circle would have these ordered pairs. So when I get ready to do the sine, remember the sine is the y value. So 0 degrees would be right here. 0 radians actually would be right here. So at that point, the y value is 0. All right, at pi over 2, that would put us up here at the top. This would be pi over 2. So at pi over 2, the y value is 1. Sine is the y value. At pi, that would be over here, the y value is 0. Okay, at 3 pi over 2, the y value is -1, because sine is the y value. Remember, we talked about any point on the unit circle would be cosine x, sine x. I'm sorry, not x, cosine theta. I do believe that when I actually wrote it in your notes, we used t and sine t for our theta. So the y value is the sine. All right, so and at 2 pi, that puts us back over here with our green dot, and again, we get 0. So if I use these values, it helps me out. Now, this is not all the values. It does continue in both directions. So the next thing we're going to do is we are going to actually draw this on an x and y axis, a rectangular plane. So we've got these values that are super important: 0, pi over 2, pi, 3 pi over 2, and 2 pi. Those are our x values. That's what we chose in our table. All right, and our y values are either 0, 1, or -1. So those are the only things that we're going to label there. All right, so I've got the ordered pair 0, 0, the ordered pair pi over 2, 1, pi 0, 3 pi over 2, -1, and 2 pi 0. And so if I connect these with a smooth curve, this would be one cycle, or one period, of the sine curve. And our period is 2 pi. If we look at the distance from 0 to 2 pi, that is 2 pi. So it completes one cycle at 2 pi. This would be one cycle of the sine curve. It does continue in both directions. My curve would continue to go just like this, and it would continue to go like that. And we would need to mark the values. You can't just randomly draw. Okay, so a few things that we are going to observe. I'm going to erase this part that I added. And so a few things that we will observe about our sine function. All right, and so one of those is the domain. Those are the x values, and now I told you it continues on in both directions, so our domain is going to be all real numbers, so from -infinity to infinity. Our range is our y values, and notice the curve only goes from -1 to 1, and I use brackets because it does equal 1. Just a reminder that sine is an odd function. All right, So those are some things we observe about y equals the sine of x. Now, unfortunately, we're not going to be graphing just y equals the sine of x. We are going to be graphing something entirely different. There are going to be some variations or transformations for the sine of x. And there are several of them. I will do them one at a time, and then we'll try to put some of them together. All right, so here's the first one. Y is equal to a times the sine of x. Now, a would represent some number, and a is called our amplitude. Okay, a is called our amplitude. The absolute value of a is our amplitude. And what it does is this stretches the graph of that original sine that we had above, stretches the graph vertically, or it might shrink it. Okay, it either stretches or shrinks the graph vertically. So instead of going up and down all the way to 1 and -1, it might only go to a half. Or it might go all the way up to 3 and all the way down to -3. So let's do an example of one of these. If I had y is equal to, let's do 3 sine of x. So my amplitude is 3. The absolute value of a is 3. And so what that means is that I have a maximum value at a maximum value of 3, and I have a minimum value of -3. Okay, that's what it means for that to be my amplitude. That's how high and how low, which would be considered a max and a min value. All right, so let's draw our little graph here. Now, the next thing that we always do when we're graphing this is we use those 5 key points. Okay, those 5 key points are super important. Now, as these graphs change, we're not going to use exactly the same 5 key points. It depends on the equation that we have. But every time, we're going to take whatever the period is, divide by 4, and this gives us the distance between our key points. All right, it gives us the distance between our key points. All right, so in this case, we have got, still have a period of 2 pi because it's just the sine function. So I would say 2 pi divided by 4 is pi over 2. Well, that's the same key points that we had before. We started with 0, and we went pi over 2, pi, 3 pi over 2, and 2 pi. Now, since our amplitude is 3, we have to go all the way up to 3 and down to -3. Now, we're going to graph one cycle, right? And so one cycle, if we relate this to the first graph that we had, okay, it's going to touch at all the same key values. But since our amplitude is 3, at pi over 2, instead of going pi over 2, 1, it's going to go pi over 2, 3. At pi, it still crosses the x-axis. At 3 pi over 2, instead of -1, it's going to go all the way down here to -3. And then at 2 pi, it's back at 0. So when I sketch my graph, this is one cycle or one period. My math lab goes back and forth between that vocabulary, so we can call it a cycle or a period of 2 pi. All right. Now, I do want to point out to you, just so that we can see, these 3 points right here are, since all we had was an a value in the front, those points where it crosses the x-axis didn't change. The only thing that changed was our max value and our min value. Instead of 1 and -1, they are 3 and -3. So the distance from that value to the x-axis is the absolute value of a. And the distance from the x-axis to this other value is also the absolute value of a. Okay? That's how far it is from that x-axis. All right. They're also going to do lots of other things for us. Okay, another example would be, what if my A value is negative? Because we just stated that our amplitude is the absolute value of A. So in this case, it would be the absolute value of -1, which is 1. Right? So that doesn't look like it changes anything, and it doesn't, in fact. But if A is negative, then what we're going to do is we're going to reflect that original function for sine over the x-axis. That's what it does for us. So I'm going to start by sketching that first graph for sine, okay, the original graph. We had pi over 2, pi, 3 pi over 2, and 2 pi. And it went from 1 to -1. Okay, so this was our original graph, the very first one that I drew. Okay, this is the graph of, and I'm going to label it just so we can know for sure, y is equal to the sine of x. That's our original graph. Now I said if A was negative, we're going to reflect it over the x-axis. Well, since this point is on the x-axis, it doesn't move. Okay. All right, so we got this point up here, pi over 2, 1, reflects over the x-axis, so it'll be pi over 2, -1. Again, this point is on the x-axis, so it won't change. The point 3 pi over 2, -1 reflects over the x-axis, and it becomes 3 pi over 2, +1. And again, this one is on the x-axis, so it won't move. So my green curve is actually the one we are looking for. Y is equal to negative sine of x. Okay, the green is the answer here, not the black. But my math lab sometimes will make you graph two of them on the same graph so you can see the transformation. All right, lots more transformations for us to look at. Instead of doing these individually, I'm going to go ahead and, well, I'll do them individually. So instead of just having an A, we could have a B value. Okay, so we could have some number being multiplied by x. Now, absolute value of A is still our amplitude. Still tells me how high and low the graph goes. Now, my period changes. Now that I have this number in front of x, my period is going to be 2 pi divided by whatever that B value is, because the original period for sine is 2 pi. Well, now that we have this B value, we have to say 2 pi divided by B, and that gives me the period of this particular function. All right, so here's what we're going to do. Another example here. We are going to determine the amplitude and the period, and then we are going to graph it. So then we are going to graph the function, and I'm going to give you some values for x between 0 and 8 pi, and it'll make sense to you in just a moment when we actually start working this problem. Okay, so every time we are asked to do a problem like this, knowing the amplitude and the period are definitely the first things that we want to know. Okay, my amplitude, absolute value of A, would be absolute value of 2, which is 2. So we know our amplitude. All right, our period is 2 pi divided by whatever the B value is. In this case, our B value is 1/2. Okay, and I don't like a fraction in a fraction. So 2 pi divided by 1/2 is the same thing as 2 pi times the reciprocal, 2. So 4 pi is my period. So here's what that means, is that this graph is going to have a maximum of 2 and a minimum of -2. Now, the period being 4 pi, what that means is that it has now been stretched out, and it will complete one period in the space of 4 pi. All right, so our next little order of business here would be, what about those key points? Those 5 key points. All right, well, let's take our period and divide by 4. That was the little formula I gave you. Well, our new period is 4 pi, and we're dividing by 4. So this means we are going to count by pi on my graph. So my 5 key points, if you need to see them in a table, would be 0, pi, 2 pi, 3 pi, 4 pi. Okay, we are going to count by pi. That's what my 5 key points, this value helps me know what am I going to count by for my x values. Right? And now I have to revisit that unit circle, and I actually have to do the work. Okay? Now, the good news is, when you draw this table, once you've decided what are your 5 key values, the y values aren't going to change except for this little amplitude over here. So typically we say 0, 0. Well, guess what? The amplitude doesn't affect that. All right? The next column where we have pi, typically it goes up to 1, but this one is going to go up to 2. Okay? 0, we're going to go down to -2, and 0. Now, you could actually compute each one. Okay, so let me show you that. 2 times, I'll compute the sine of 1/2 times pi. Okay. Well, that's the sine of pi over 2 is what that is. Well, the sine at pi over 2, think about your unit circle. The sine at pi over 2, my y value is 1. So 2 times 1 is 2. So my y value is 2. You could actually plug it in, plug and chug, or we could relate it back to the very first graph. Our 5 key points, the y values are going to be just like the y values in the original graph, except the amplitude. Where it said 1 and -1, we change it to whatever our new amplitude is. All right, so let's graph our function. I'm going to write it down again just so we are all clear of what we are graphing. All right. We said we were going to count by pi, so pi, 2 pi, 3 pi, 4 pi. Now my direction said go all the way from 0, which is why I started with an x of 0, to 8 pi. So 5 pi, 6 pi, 7 pi, and 8 pi. My magnitude is 2. Sorry, my amplitude is 2. So I have to go up to 2 and down 2. All right, and now I'm ready to graph. I'm going to do it in blue. All right, so I've got 0, 0. At pi, we go up to 2, back to the x-axis, down to -2, back to the x-axis. All right, so we have created one cycle or one period. Okay, the directions wanted us to go all the way out to 8 pi. Awesome. So it repeats itself. All right, so you don't have to make any more, plug anything else in. It repeats itself. Once you've got the first period, it just starts over again. So we're at 0, 0. I'm sorry, 4 pi 0. Then we will be 5 pi 2. Go back to the x-axis, down to -2, and back to the x-axis. And so now we have graphed 2 periods of the sine function to sine 1/2 x. Notice that our one cycle went from 0 to 4 pi, which we said that was the period was 4 pi. It completes one cycle from 0 to 4 pi. This is going to take some practice if you've never graphed trig before by hand, because we're not doing it with our calculator. All right, and so then we've got 2 other things that could happen. All right, we could have this little, we could have not just a bx, not just an a, we could have a c, and we could have a d value. So let me just review what all of that stands for. Absolute value of a is still our amplitude, how high and low. I spelled that incorrectly. My period, we do it exactly the same way, 2 pi divided by b. Okay, that hasn't changed. Okay, now since I do have a c value, that does change things for me. That gives me a phase shift. Now what a phase shift is it moves the original graph left or right. Moves that original sine function left or right. Okay, it's just a transformation, a phase shift. Okay, well, to find that phase shift, like how far does it move it to the right or to the left, we take our c value and we divide by b. Now, what that does, when I say c divided by b, that is my new starting x value. So like in my table. All right, that is my new starting x value in my table. Okay, sorry, I had a text I needed to answer. Okay, so we got what that tells me. So here's how we will do that. Since that's our new phase shift, I need to know, okay, if that's where it starts, well, where's it going to stop? So here's what I can do. I can take this bx minus c. I know that I usually start at 0 and I usually stop at 2 pi for one period of the sine curve. So if I take this and I solve it for x, okay, so I add c to both sides. Now that's, okay, let's hold off on doing that. We'll just wait. But this is the general idea, is that that will tell us where the cycle starts and where the cycle stops. If you can find the new starting value, that's really the only one we're going to work with. So let me find a problem for us to do that has a b and a c value. Okay, so let's graph y is equal to 3 sine 2x minus pi over 3. Now I know I haven't told you what d is yet. Okay, I'm not going to do d in this particular problem, but I am going to go ahead and tell you what d does. D is a vertical shift. I didn't mean to say equals and is. D is a vertical shift. Okay, so it moves the entire graph up or down, depending on whatever it says. And we'll do one of those also. Okay, so for the moment, all I have is an A value, a B value, and a C value. I don't have a D in this particular problem. All right, so my amplitude is 3. My period is 2 pi divided by my B value of 2, which is pi. Now I have this C value, so my phase shift is this C value, which is pi over 3, divided by my B value of 2. Okay, I need to simplify that. And I get pi over 6. All right, this is my starting X value, okay, for my table. That's my starting x value. So I'm going to move it to the right a little bit so I have some more board space. All right, that does give me my starting x value, the start of a cycle. All right, now that means that in my little table, I am going to start with pi over 6. I'm not going to start with 0. Now, I need to know what am I going to count by. All right, now that's what the 5 key points, that little thing that I showed you where we take the period and we divide by 4, that helps us know what we count by on our 5 key points. Our period we found was pi, and we divide by 4. So we're counting by pi over 4. On my table. All right, so I'm going to go back down here to my table. And so to find this next value, I have to say pi over 6 plus pi over 4. All right, now you've got to get a common denominator. So that would be, I'm going to work this one completely out so you can see it. So that would be 2 pi over 12 plus 3 pi over 12, which would be 5 pi over 12. So that's my next value, 5 pi over 12. So that made a really big space. Okay. My next value, I'm going to take this 5 pi over 12, and I am going to add pi over 4. Now, I already know what the common denominator is because I just did it right here. Okay. I took pi over 4 and I changed it to 3 pi over 12. So this pi over 4, I can think of it as 3 pi over 12. So I've got 5 pi over 12 plus 3 pi over 12 would give me 8 pi over 12. Okay, so in my next one, again, I'm going to add 3 pi over 12. So I get 11 pi over 12. And then my last one, plus 3 pi over 12 gives me 14 pi over 12. Oh, you need to simplify that. So I get 7 pi over 6. All right, so my 5 key values are pi over 6, 5 pi over 12, 8 pi over 12, 11 pi over 12, and 14 pi over 12, which simplified to be 7 pi over 6. Okay, so I'm not going to put this one on my graph. I'm going to put the simplified one. Awesome. All right, so I'm going to start graphing. All right, so 1, 2, 3, 4, 5 key values. I'm starting with pi over 6, and then 5 pi over 12, 8 pi over 12, 11 pi over 12, and 7 pi over 6. Those are my values. Now, we said that our amplitude of this particular problem was 3. Let me scroll back down just so we can all see that. Okay, we said our amplitude was 3. Way over here. Oh, I am so sorry. We said our amplitude was 3 over on the left of my screen there. Okay, so what that means is in my table, all right, remember we usually start at 0, and this value is 0 for my y. Okay, the next value is usually 1, but my amplitude is 3. So it changes to 3. 0, negative 3, 0. I didn't even have to do the trig part to figure that out. It's just related to that very first sine graph. All right, so my y values go from negative 3 to 3. Now I'm ready to graph. All right. Let's choose a different one. Let's do blue. All right, so at pi over 6, I'm at a y value of 0. Notice I did not start at the origin. Started at pi over 6. At 5 pi over 12, I go up to 3. At 8 pi over 12, I'm at 0. At 11 pi over 12, down to negative 3. And at 7 pi over 6, I'm back to 0. There is one cycle, or one period, of the sine function. Notice, the distance from pi over 6 to 7 pi over 6 is 6 pi over 6, which is pi. The period is pi. We already did that. So this would be our graph. Can be really complicated. You're going to need to practice. Okay. Let's keep going. Now, before I worry about that whole D, we're going to go ahead and do cosine because we need to get finished here. Alright, so y equals the cosine of x. Now we are going to start with our original graph, very similar to the way we did sine. We're going to use these 5 key points that are on the unit circle. Alright, and if we revisit that unit circle, we know that the cosine at 0 is 1, the cosine at pi over 2 is 0, at pi is -1, at 3 pi over 2 it is 0, and at 2 pi it is 1. Remember, cosine is the x values. So, every time we graph these, even though we're going to have variations of the equation, my y values are going to be just like this. Alright, my y values will be just like that, except for if I have an amplitude that's not 1. I would change those y values. Now, the x values will not always be what's there. If we pay attention, let's go ahead and graph that so we can see what it looks like. Alright, so 0, 1, pi over 2, 0, pi -1, 3 pi over 2, 0, and 2 pi 1. So, this graph looks a little different than the sine curve. I mean, it's still a curve, but it doesn't start at the origin. And so it looks like a U if we just graph one period of the cosine curve. It looks like a U if we just graph one period. Now, just like sine, it does continue in both directions, and so ultimately it will look exactly like sine. And so you have to be careful about where does it start, like does it start at the origin? So we have to be super careful. All right, so our domain for our cosine function is also -infinity to infinity, keeps going. Our range is the same thing as sine, -1 to 1. We already said the period was 2 pi, and cosine is an even function, and that's something we said in a different lesson. Now, we could have variations that have A, B, C, and D values, just like we did with sine, and the result is exactly, well, it's very similar. It's not exactly the same, it's very similar. Because you are working with cosine. So let's do one that's got an A, B, and a C. And we will graph it. All right, so we have an A value, we have a B value, and we have a C value. So just as a reminder, absolute value of A is our amplitude, right? Our period, the original period for cosine is 2 pi. So to find my new one, I say 2 pi divided by B, just like with our sine. Right? And then there is a phase shift because there is a C value. And you do find your phase shift just like you did for sine. You take your C value and you divide by your B value. And this is your starting point on your table. Actually, instead of saying starting point, how about I say starting X value? Because it's just the X value. It's the new starting X value on your table. In our table for cosine a moment ago, we started with 0, but we're not. We're going to, whatever this phase shift is, that's where we will start. Okay, so let's write down all the things that we know. We know our amplitude in this case is 3 over 2. We know our period is 2 pi over 2, which is pi. And our C value, now let's be careful, right? If you will notice right here, this says plus. Well, the original problem that I gave you said that would have to be a minus. So my C value in this case is negative pi. So we're going to put negative pi over my B value of 2. So this is my new starting value on my table. So I'm going to draw the table so that we can see it. So we're starting at negative pi over 2. All right. So let's be careful here. Now we need to know, when we do our 5 key points, what do we count by? Our 5 key points are in our table. We count by the period divided by 4. In this case, we found our period was pi. Divided by 4 means we're going to count by pi over 4. So we add that to each x value in our table. So negative pi over 2 plus pi over 4, and that answer is going to go right there. And we get 3, I'll write it down just so everyone can see it. Negative pi over 2 plus pi over 4. I need a common denominator. Right, negative 2 pi over 4 plus pi over 4 gives me negative pi over 4. Okay, to find my next x value, I would add pi over 4 again. That one's a little easier. Negative pi over 4 plus pi over 4 is 0. Okay, plus pi over 4. That should have been a 4. All right, and we need one more value. So plus pi over 4. So pi over 4 plus pi over 4 gives me 2 pi over 4, which is pi over 2. All right, now I didn't give you any directions of how many I want you to graph. If I said 1 period or 2 periods, I didn't say that. So we're going to graph what we have in our table now. All right, so negative pi over 2. Okay, negative pi over 4. I did not draw a very good graph here. Let me try that again. Okay, these x values that I have marked here in our table are the values that are important. So we're going to go negative pi over 2, negative pi over 4, and then we've got our 0 right there, pi over 4, and pi over 2. So those are my 5 values. We said our amplitude here was 3 over 2. So if I label 1 and negative 1, because I don't usually label a fraction, I know I'm just not going to go all the way up to 1 and negative 1. All right, so in my table, cosine, remember we're going to use the y values that were before. So our cosine here would be at negative pi over 2. My cosine, in our original cosine, we had 1, okay, under our starting value because we had 0, 1. So instead of 1, we use 3 over 2, 0, negative 3 over 2, 0, and 3 over 2. To help decide, just like we did before, my y values stay with the y values I used for the original cosine. The only thing that changes is my amplitude. All right, so I'm ready to graph. So negative pi over 2, I'm going to be up at 3 over 2, so somewhere around in here. Okay, not quite 1. At negative pi over 4, I'm at 0. At 0, I'm going to be at negative 3 over 2. Okay, so hopefully you guys noticed that I just said that wrong. 3 over 2 is bigger than 1, not smaller than 1. Let me do that again. So this is 1. So I have 2 up here, negative 2 down here. Let me just clarify. 3 over 2 is 1.5. Okay, so it is in fact bigger than 1. All right, so let's go back. At negative pi over 2, we're going to go to 1.5, so it is going to be above 1. At negative pi over 4, we're at 0. At 0, negative 3 over 2, which is negative 1.5. At pi over 4, 0. And at pi over 2, back up to positive 3 over 2. So when I draw my curve, it is a really steep one. And notice it looks like a U. So this would be one cosine curve using the equation that was given in this problem. So this would be y is equal to 3 over 2 cosine 2x plus pi. I think the trickiest part there was that knowing that c was going to be a negative value. Now these are really big problems. I understand how frustrating it might be when you try to sit down and work some of these. I'm going to do one that has a d value. I told you I would. So I'm going to do one that has a d value. I won't make it one of the most complicated. So let's graph y is equal to 2 cosine x plus 1. Now, the reason I know that the 1 is a d value is because it's not in parentheses, right? So this is a d value. I don't have a c value this time. I do have a b value of 1. My a is 2 and my d is 1. Okay, so the reason I know that's a d is it's not in parentheses. If x plus 1 had been in parentheses, then the 1 would have been a c value. Actually, negative 1 would have been my c value. All right, so let's point out all the things we know. We know our amplitude is the absolute value of 2, which is 2. Our period is 2 pi over the b value, which in this case was 1. Okay, and since d is equal to 1, I know that I have a vertical shift up 1, okay, because it's positive 1. So let's just talk about what does that mean about our maximum and our minimum. We usually at cosine have a maximum of 1, but our amplitude is 2, so we're going to add 2 to that, and our new maximum is going to be 3. Right? We typically have a minimum value of negative 1, right? But we are going to shift this thing up 1, right? And then our amplitude is 2. So a little crazy there. What we're going to do is we're going to say 1 minus 2. Right? If we're shifting it up 1, we're going to go, maybe we should just look at that on the graph if that's a little confusing to you. And there is no phase shift here. There is no phase shift. It doesn't move left or right. So we don't have to worry about that starting point being a different value for our x values on our table. We get to use our x values on our table from the original. So 0, pi over 2, pi, 3 pi over 2, and 2 pi, because there was no phase shift, all right? And our period is 2 pi, so that did not change, so we don't have to count by anything different here. So we can just use these values. All right. So now we need to figure out what goes in our table. At 0, typically for cosine, this would be a 1 right here, but we're going to replace it with a 3, okay? Our maximum value. At pi over 2, we typically would be at 0, but we shifted it up 1. Okay, so we would be at 1. at pi, we would be at -1. We would normally be at -2 because of that amplitude, right? But we shifted it up 1. So as we graph this, it will make a little more sense to you. At 3 pi over 2, we'll be at +1, and at 2 pi, we will be at 3. So let's think about it like this. The first thing I'm going to graph is the original cosine function. Okay, just the original cosine. I want you to see it happen as I graph it. All right, so the original cosine goes like this. These are our values. Okay, this I should have actually gone through there. Try that again. Okay, there we go. So this is just the original y equals cosine of x, the first one that we graphed for cosine. I'm going to graph this one in like an orangey color. All right, so we shifted the whole thing up 1. So typically my x-intercepts are at pi over 2 and 3 pi over 2. Well, if we shift this thing up 1, it's like I have a new x-axis, okay? We shifted it up. So at pi over 2, it is going to cross that line. At 3 pi over 2, it is going to cross that line because we shifted it up 1. And now you can see it matches my table up there. All right, and so if I take the value right here at 0, 1 on the original function, okay, this one at 0, 1, right, and I shift it up 1, right, and then it says that I have a phase shift, I have a vertical shift of 1, but my amplitude is 2. So it has to go all the way up to 3. I've already looked at it there. So instead of going up to 1, it's going to go up to, whoops, wrong color. Okay. So let's think about it like this. Here's what we could do. We could do it in parts. Okay, let's start by making everything go up 1. So this goes up 1, and then this value that's down here goes up 1. This value that's out here goes up 1. Still not the answer to my curve. Okay, all I have done right here is shift it up. So this is just the cosine of x plus 1. That's all I've done there. Everything got moved up 1. Well, the amplitude of 2 means how far it is from the x-intercepts. So here's how we have to think about that. We moved that x-axis up, so my amplitude goes from here. It's the distance from where it crosses the x-axis. Okay, so the distance from, we imagine my new x-axis would be this line. Okay, we shifted it up 1, right? The amplitude says I'm going to be 2 spaces from there. So it would be right here. So I'll wrap this one in green. All right. And then I've got this other one at 2 pi. I want to go also to 3. So I'll go up here to 3. Right? And at pi, I want to go down to -1. Okay, so the green dots, okay, I've already got at pi over 2, I'm at 1. I've already got at 3 pi over 2, I'm at 1. So these green dots would be our actual graph of y is equal to 2 cosine x plus 1. This is so much easier when I can look at your faces and explain to you. So if I have to graph one of these again, I will gladly do that for you. I know that's a little confusing to have us see it this way. So here's the way we imagine it. The original cosine graph is black. And the first thing I did was move it up 1, and that one became the yellow. So all my little points got moved up 1, and now I have this orangey yellow graph, right? Now I take care of my amplitude is 2. So I created, let me draw it a different color just so we can see it. Okay, we shifted the whole graph up 1. So let's imagine that this red line is the new x-axis because it got shifted up 1. My amplitude goes from that line to the highest point. That is my amplitude. And it also goes from that line to the lowest point. That is my amplitude. My amplitude is 2. From that line to my minimum has to be 2 spaces. From that red line to my maximum has to be 2 spaces. So hopefully that clears that up a little bit. Okay, one last problem that my math lab is going to throw at you. Can't get my screen to move. There we go. Is they're going to say, you know what? I'm going to give you the graph and I want you to find an equation for the graph. Now, they are going to be a little bit lenient with you, and they're going to say, you know what, your answer to be A equals the sine of BX, or, depends on how you see it, you might see A equals the cosine of BX. Now, obviously, we can't have A and B. We have to actually have numbers. So I'm going to draw you the graph that, like, will already be given to you for you to answer. So what you're going to do is you're going to look at this graph and see if you can decide what the equation is. All right, so here's the graph. And so you will be given a graph in my math lab and you'll be asked to write an equation for it. And so when you look at it, do you see a sine curve or do you see a cosine curve? Because remember I said they look so much alike. Now here's how I decide. The reality is you could give either one and be correct, but they are different answers, like the A and B values are different. Okay, so let's say I just look at this and I go, you know what? I know that the cosine curve looks like a U. So here's what I look at. There is one cosine curve. That's what I look at. And in that green curve, here are the things that I notice. I notice that the amplitude is 2. And I notice that the period, one complete cycle, goes from 0 to 4 pi. So my period is 4 pi. Okay, those are things that I can tell from that, just tracing the green portion, one cosine portion of this curve. Okay, well here's what else I know, is that the period is usually found by saying 2 pi divided by b. Well, we just said that the period was 4 pi. So let's solve this for b, which means I would multiply both sides by b, and then divide both sides by 4 pi. And so I get that b is 1/2. 2 over 4 is 1/2. So I know the b value is 1/2. I know the a value is 2. Well, look at there. Those are the two things that I need to write my equation that it was asking me for. So y is equal to 2 cosine, move my board over a bit. We said b was 1/2 x. There we go. There we go. It's definitely easier to do the cosine one in this case. You could have done sine. It's a little bit more complicated because there is a phase shift if you choose to do the sine, which means there would have to be a c value. And they did not want you to give it one that had a c value based on the directions here. Okay, I know that that was a very long lesson. So thank you for sticking with the whole video. Hopefully it's not too terribly confusing, but please come to Teams and I can maybe clear up some confusion if you are confused about anything. So hopefully this is not too bad. Go ahead and make sure that you, after you watch this video and take notes, that you go ahead and try to do the assignment. Let me know if you have any questions.